Okay, so this is YouTube homework number 2, uh, number 91. Before looking at the question, I drew a V versus T diagram first. I noticed that at first the car was going with some initial velocity, and then at the responding time, the driver hit the brake, and the car began to slow down, so the velocity is decreasing right here, and eventually come to a stop. Okay, A, the stopping distance. So I divided this problem into two parts. So the first part is the car going with some initial velocity before hitting the brake. So I got that the stopping distance for part A is the area under this curve only. So that would be the area of the rectangle right here. So I got that the length of the rectangle is equal to t equals 0 second to the responding time. So that would be just be the responding time. And the height would just be the initial velocity. So the area of this whole rectangle is just the initial velocity multiplied by the responding time. And that would be your delta x1. So for part B, I use the kinematic equation number 3. So that is v squared equal to the initial velocity square plus 2a times the displacement delta x. So basically, at the stopping point, the velocity is going to be equal to 0. And we already got the v initial. And all we have to do is solve for delta x using this equation. So we move the v initial square on this side, and we divide it by 2a, or 2a prime in this case. So I noticed that the a is gonna be negative because the slope of this part, like this slope right here, is negative. So a negative along with a negative will cancel out, so you get a positive delta x squared distance, which makes sense. After that, so your delta x total, your total displacement or stopping distance would be the stopping distance for part A and the sloping distance for part B. So that would be your delta x total. So I noticed that when you're looking at this, if you replace the v initial with an x, then you would get an x squared over 2a prime plus the responding time multiplied by an x. So that looked to me like a quadratic. Therefore, I plugged the data table into my calculator and click on quadratic regression, and I got this equation: y equal to 0.0553 x squared plus 0.6599 x minus 0.06, which makes sense because at first you can already see that this is going to be a quadratic formula of some. So to solve for a prime, I set this expression equal to this, because if you take the v initials square as x, then you get the same expression. So I tried to solve for a prime, and I got that a prime equal to 9.04159 meter per second square. Then that would be your acceleration. And then for part C, the responding time. So again, if you set the v initial equal to x, then you'll see that the TR is equal to the term right here, which is 0.6599 seconds. So that would be your responding time.